Hi and welcome to 3.1, a new unit. We're going to start with something called a similar triangles. I would like you to take a look at these four different colored triangles I have here and ask yourself which one doesn't belong. Now, people will have different answers. I would say a lot of people might say the red one because it's got a different orientation, like it's kind of pointed upwards versus the other ones. So which one doesn't belong might depend upon your point of view. But if I ask a different question, if I ask which triangles are similar, there's only one right answer. And by similar, I mean the special meaning that we have in math. And when we talk about similar triangles, we mean that not just what's different about them, but do they have the same shape? So that's the first thing I'm going to put on here, and maybe I'll just write it over here. Similar triangles have the same shape. Well, the blue and the green triangles definitely have the same shape. Now, in fact, if I just go and switch to over here, yeah, if I look here and I can drag this one over top and I can say, you know what? Here's the test for the same shape. Are the angles the same? So it looks those are exactly the same. If I check the purple one, no, these angles look like this 90-degree one is, but that angle's different. What about the red one? Well, this is kind of cool. I can rotate it. It's still the same triangle. I've just rotated it. Now when I look at it, it'd be like, okay, the 90-degree angle is, this angle is, that angle is. So when I say it's the same shape, another way of saying that is to say that the corresponding angles are the same. So I'm going to write that in here. So I've written corresponding angles are equal. Now, what do I mean by corresponding? Well, I can sort of show it by labeling. Clearly, this is a right angle, this is a right angle, and this is a right angle. So those angles are equal, they correspond. This angle is equal to that angle, which is equal to, I have to think about it, this angle there. So those ones are corresponding. And now I'll indicate this one with 2 marks to show that it's different. 2 marks here and then 2 marks here. So that's what I mean by corresponding, because I could get a little bit sloppy if I say if the angles are equal. Well, like this angle is different than that angle, and this angle is not the same as that angle. But if I put little equality marks on it, and I show, okay, now this angle, here I can even highlight it, this angle corresponds with that one with corresponds. So that's just what that means. Corresponding angles are equal. The third thing that similar triangles have, and you can identify them as having the same shape, and you can identify that the corresponding angles are equal, but the last one is that the sides are proportional. So we're going to talk about that a little bit later on, but just remember what a proportion was. Like say if I had 2 over 4 is equal to something over, I don't know, 12. You might look at that and say, hey, you know, here I've multiplied this times 3. So if I multiplied that times 3, then this side would be 6. Same idea here. Like let's say if this side and this side, let's see if that was like the bigger one was exactly twice as much. If this was 4 and this was 8. And then if this is 3, then I wonder what that would be. Well, 4 times 2 is 8, 3 times 2 is 6. So that would work as well. So that's what I mean by sides are proportional. And if you recall, we spent some time solving these for ones that aren't easy by using a little bit of math to solve for x. All right, let's do a little bit of geometry notation or how to talk about triangles. I'm just going to label these. Okay, so I'd like you to label them exactly the same. So I did A, B, C, and then D, E, F. And then I want to talk about which angles are equal. So just a reminder then that these are right angles. This one is equal to that one, and this one is equal to that one. So if I write this out, I could say that angle A is equal to angle E. Now I'd have to make sure I was being careful with that and doing the right one. Angle B is equal to angle D, and then I could say angle C is equal to angle F. So therefore I know, because the corresponding angles are equal, that's what I've just proved, then I know that the triangles are similar. So I could write, so triangle ABC. Now here's the similar is similar to triangle. I have to make sure I get the order correct. So I can look, ABC was E, D, F. It might bug some of you that that's not an alphabetical, like it's not D, E, F, it's E, D, F, but that's the way that the letters are made. So that's how I write that they are the same. So that means they are similar. Okay, I'm also going to mention if they were exactly the same, like if I had, you know, this one, and they were the same angles and the same size, then I could say congruent. Okay. Congruent would be not just the angles, but also the sides. So I'll put, you know, the same number of equality marks each time too. So if two angles are congruent, they are also similar because their angles are, and everything is going to be the same. So congruent, another way of saying it is to say identical in all ways. Similar just means angles are equal. Okay, let's take a look on the next page here. It says, example number 1, are these triangles similar? Well, really what I'm asking is, are the corresponding angles equal? And if I look at these little equality marks, there's 1 here, 2 there, 2 there, 3 there, 3 there, I could say yes. In fact, I can even write it. I could say triangle ABC is similar to triangle EDF. Are these triangles congruent? Yes. Here, I'll show you how to do the congruency. Triangle ABC congruent with a dot over top, or equals with a dot over top. And same idea, I have to get the order of the letters right. Okay, we don't have to do that every time. I'm just showing you how. Example number 2. Are these two triangles similar? So in other words, are the corresponding angles equal? And I look at the marks and I see yes. Are they congruent? No. And some of you might notice that this one, the sides are twice as big, right? Example number 3. These two triangles are similar. Find the unknown value. So we're going to set up and first of all, there's not a really easy, like, 6 times what gives you 9. It's a little bit complicated, so we'll set this up and solve it using our algebra skills. So I'm going to put 2 fractions again. This one will be for the big triangle, and then this one over here will be for the small triangle. And so if I go maybe 12 over 9, and I'm just got to make sure I get the order right. So 12 corresponds to x, those are the corresponding sides, and 9 corresponds with 6. So when I go on the other side over here, I got to make sure that I put the x on the top, right? I don't want to put the x on the bottom, so we need to be careful. So, if we're looking here, these two ones have to be corresponding sides. Alright, so now I want to solve for that. I would say, okay, so I'm going to multiply x times 9, so I get 9x equals the other way, cross multiplying 12 times 6. 12 times 6, if I get my calculator, is 72. So I'm going to say 9x is equal to 72. Now to get x by itself, I'm going to divide both sides by 9. 9x divided by 9 is x. 72 divided by 9 is 8. And there's my answer. Excellent. All right, so that's it. And then there's a bit of a worksheet that you can do. And just a reminder that you can look way over here at the beginning. There is this QR code or a URL so you can get answers for the worksheet. All right, and I will see you in class.